morning friends. Today we are going to discuss previous year question paper from 2013 to 2020 real analysis question paper. This is from Karnataka Kset question paper. This is a 2020 question paper. First question: the number of pairs of integer a and b satisfying 0 is less than a is less than b and a raised to b equal to b raised to a. Here ask the number of pairs integers a and b satisfying 0 is less than a is less than b and a raised to b equal to b raised to a. Here only one number exists, that is here a equal to 2 and b equal to 4, that is a raised to b equal to 2 raised to 4 is equal to 16 and b raised to a equal to 4 raised to 2 equal to 16. Therefore answer B is correct. Next question: let sum runs from 0 to infinity 2n factorial 3n factorial upon n factorial 4n factorial. This is the one, and sum n runs from 1 to infinity 1 upon n raised to 3n plus 2 upon 2n. This is the second equation. Then this is the divergence convergence. Here given this is the solution of here this is the first example. That is written as a here an is a 2n factorial 3n factorial upon n factorial 4n factorial, here n, and 1 this is the limit n tending to infinity n plus 1 upon n, that is written as a 2n plus 2 factorial 3n plus 3 factorial upon n plus 1 factorial 4n plus 4 factorial into this is a an and this is a an plus 1, and next is a multiply and multiply, and finally we get this one, and finally 2 into 2 into 3 into 3 as n tending to infinity, here 2 2 3 3 3 1 4 4 4 4 and cancel 4 and 2 2, finally we get 27 by 64, that is a less than 1. Therefore this is a convergent. And next is a this is a second example. Sum n runs from 1 to infinity 1 upon n raised to 3n plus 2 upon 2n. Here an is a this one, that is a here written as a, and n raised to 3n plus 2 upon 2n, that is written as a n raised to 3 by 2 into n raised to 1 by n. Let us suppose here 1 upon 3 raised to n equal to bn, and by limit n tending to infinity an upon bn equal to 1 upon n raised to 1 upon n equal to 1, by this is the sum of bn is a convergent, so it is also convergent. Therefore example 1 and 2 also convergent. Next, therefore option C is correct. Next question: this is for your homework. The series sum n runs from 1 to infinity minus 1 raised to n 2n plus 1 upon 3n plus 5 is a divergent. This is the example of a divergent. Next question: the radius of convergence of the power series sum n runs from 1 to infinity 1 plus 1 upon n 1 plus 2 upon n up to 1 plus n upon n into z raised to n is here given option 4, and this is solution. Here one how to find radius of convergence? This is the formula for radius of convergence. 1 upon r equal to limit superior n tending to infinity n raised to 1 upon n. Let k equal to limit n tending to infinity 1 plus 1 upon x, 1 plus 1 upon 1 plus n upon n raised to 1 upon n. Here 1 upon k equal to r. That is this. And log on both sides. Log raised to k equal to limit n tending to infinity 1 upon n sum log 1 plus r upon n. Next one is the integration 0 to infinity log 1 plus x dx. Here put r upon n equal to x and then 1 upon n equal to dx. By integrating path x, this is integration, and put this value and finally we get k equal to 4 by e. That is 1 upon k equal to e by 4. That is the radius of convergence. So option A is the correct. Here option A is the correct. Next question. The set closed interval e to pi intersection q is a compact, connected, compact but not connected, neither compact nor connected. We know that q is not a closed. Q is not a closed and q is also disconnected. Here check, q is disconnected. Q r minus q, q complement n z are disconnected. And here ask e pi intersection q. Here interval are uncountable. Interval are uncountable and r is isomorphic to interval. Here q is in subset of r, therefore q is not disconnected, means q is not connected and not closed. Here not closed, not disconnected, therefore this is not compact, therefore neither compact nor connected. Answer D is correct. Next question. Suppose that g from r to r is continuous on r and g of x equal to 0 for every rational x. Then g of root c1 equal to 0. This is a continuous. Next question. Let fn from r to r be differentiable for each n runs from 1 to with modulus of fn dash of x is less than or equal to 1 for all n and x. Assume limit n tending to infinity fn of x is equal to g of x. Then here is the one result, differentiable plus bounded derivative, then implies this is a continuous. Here given a differentiable and plus bounded derivative, here also given a bounded derivative is less than or equal to 1, then implies this is a continuous for all x. This is a continuous for all x. A is the correct. Next question. The sum of the series 1 square upon 1 factorial plus 1 square plus 2 square upon 2 factorial plus 1 square plus 2 square plus 3 square upon 3 factorial plus dot dot dot. Here answer is 17e upon 6. Next question. The value of limit n tending to infinity n raised to root 3 upon 1 plus root 2 raised to n is here is one result. If an is a sequence of a real number such that a limit n tending to infinity an plus 1 upon n equal to L, here modulus of L is less than 1, then limit n tending to infinity an equal to 0. This is a result. Therefore, you can solve. Answer we get option C, 0. Next question. Which one of the following statement is the false? Here ask a not a true statement, that is false statement. If f is bounded and a finitely many discontinuity on closed interval AB, then f is the Riemann integrable on closed interval AB. This is a correct statement. Here check set of finitely many discontinuity, finite number of discontinuity, then implies this is a Riemann integrable. Continuous, then implies Riemann integrable. Uniform continuous, then implies Riemann integrable. Bound differentiable, then implies Riemann integrable. And bounded variation, then implies also Riemann integrable. And monotone implies Riemann integrable. And set of point of discontinuity of a function f as a major 0, then implies also Riemann integrable. And set of point of discontinuity of countable number of limit point, then also Riemann integrable. This is important. Here in option A, if f is a bounded and has a finitely many discontinuity on closed interval AB, then f is a Riemann integrable. This is also correct. F is a monotonic. This is also correct here statement. And this is and f is a continuous, then f is a Riemann integrable here. And next one is this is a if f and g are not Riemann integrable on closed interval AB, then fg is a may or may not be integrable on closed interval AB. Therefore, this is a false statement. Next question. Let f from R2 to R1 be defined by f of xy equal to xy upon x square plus y square if xy is non-zero. 0 if xy equal to 0. Which one of the following statement is true? Here f is the continuous at 0, 0. Answer is B. Next question. Limit n tending to infinity 1 upon n into 1 upon 2 plus 2 by 3 plus up to n upon n plus 1. Here option given 0, infinity, 1 and limit does not exist. Here is the one result, important result. If an converges to L, then the sequence xn equal to a1 plus a2 plus up to an upon n also converges to L. And limit n tending to infinity an equal to L, then implies this is also L. Here given this statement, and now find limit n tending to infinity n equal to L. Here put n tending to infinity n upon n plus 1, that is equal to 1 upon 1 plus limit n tending to infinity 1 upon n, that is as n tending to infinity 1 upon n tending to 0, and finally we get 1 upon 1 plus 0 equal to 1. Therefore option C is correct. Next question. For all x is greater than 0, the inequality e raised to x is greater than x raised to t holds if and only if. This is the most time repeated question. This is a very important question. T is less than e. Correct answer is. Next question. Let the sequence xn be defined by x1 is equal to 1. Let the sequence xn be defined by x1 equal to 1, x2 equal to 2 and xn plus 1 equal to xn plus xn minus 1 for n is greater than or equal to 2. Then find limit xn plus 1 upon xn as n tending to infinity. Here 4 option given. Here given. Now find the limit tending to infinity xn plus 1 upon xn. Here xn is given. Here this is xn given, and xn plus 1 is also given. Xn plus 1 equal to xn plus xn minus 1, that is written here, and upon xn, and xn upon xn plus 1 upon xn upon xn minus 1, and put xn upon xn minus 1 equal to L as a limit, and L equal to 1 plus here xn upon xn we get 1 and 1 upon this is a L, and here also L equal to 1 plus 1 upon L, and multiply by L, and L square minus L minus 1, and find roots are 1 plus or minus root 1 plus 4 upon 2, that is 1 plus root 5 by 2. Here taken only positive root in option, and we get option D is the correct answer. Next question, limit n tending to infinity, product of k runs from 1 to n cos pi by 2 raised to k. Here option given, and now check for, we know that cos pi by 2, here put k equal to 0, and cos pi into, here put k equal to 1, cos pi by 2 into dot k equal to 2, and up to here cos pi by 2 equal to 0, therefore product into other multiply also 0, therefore option C is correct. Next question, 1 upon pi integration minus pi to pi x raised to 5 cos 5x dx equal to 0. This is for your homework. Next question, let f from R2 to R be a sum function, then which one of the following statement is the true? Here ask a true statement, other 3 statements are false. Now check for, if f is a continuous at point, then f has a partial derivative at that point. Continuous, then m plus partial derivative. This is not a true, because partial derivative plus bounded, then m plus continuous converts not a true, therefore option A is correct. In option B, if f is a partial derivative at a point, then f is a continuous that point. Partial derivative at a point, this is also not true, because here partial derivative exists plus bounded, then implies continuous, therefore option B is also wrong. Now check for option C, here f has a partial derivative at a point, then f is a differentiable at that point. Here given a partial derivative at that point, then implies this is a opposite to differentiable, this is not true. Differentiable implies existence of a partial derivative. Here this option also wrong. Here ask if f is a differentiable, then f has a partial derivative at that point. This is a true statement, so option D is correct, other option will be wrong. Next question, the sum of the series, here given 15 upon 16 plus 50 upon 16 into 21 upon 24, answer we get B. This is also for your homework. Next question, the sum of the series 1 plus 1 upon 3 plus 1 upon 5 plus 1 upon 7, here are 4 option given, and now check for here one formula. Here one formula, log b log root b plus 1 upon b log a by b. Here a is the number of positive term, here 1 2 3 4, here 4 positive term, and number of negative equal to b, here given 1 2, here a equal to 4, b equal to 2. Put this value in this equation, and log 2 plus 1 upon 2 log 4 by 2, that is log 2 plus 1 upon 2 log 2. Finally we get 3 by 2 log 2. Option A is correct. Next question, the series sum runs from n raised to 1 to infinity 1 upon k plus minus 1 raised to k upon k square. Now check for apply sum 1 upon k plus minus 1 raised to k, here also sum and 1 upon k square. Here 1 upon k is a divergent, and this is a no matter convergent or oscillatory, therefore one statement. Here an is a convergent and bn is a divergent, then sum of an plus or minus bn is a divergent, therefore one is a convergent and one is a divergent, therefore option sum will be divergent. Next question, let an be a sequence of positive real number such that limit n tending an plus 1 upon an is less than 1, then limit n tending to infinity an. Here one result, if an is a sequence of a real number such that limit n tending to infinity n plus 1 upon n equal to L. Here modulus of L is less than 1, then limit n tending to infinity n upon n equal to 0. Here positive real number and such that this is a direct result, limit n tending to infinity n plus 1 upon n is less than 1, then limit n tending to infinity, finally we get 0. Option A is correct. Next question, if n is greater than 0 for all n is greater than or equal to 1 and sum n runs from 1 to infinity n converges, then sum n runs from 1 to infinity root n into n plus 1. Here is given n is greater than 0 and for all n is greater than or equal to 1 and sum of n is converges, then their product also converges. This is also converges. Next question, limit n tending to infinity n plus 1 root n plus 1 factorial minus nth root of n factorial. Here we get answer E inverse, that is 1 upon E. Next question, which one of the following series diverges? This is a conditionally convergent, and now check for option D. Now check for option D. Here the sum n runs from 1 to infinity minus 2 raised to n upon n square, that is written as the sum n runs from 1 to infinity minus 1 raised to n into 2 raised to n. Here common minus 1 raised to n, 2 raised to n upon n square, put an equal to 2 raised to n upon n square. As the limit n tending to infinity, an equal to 2n upon 2 raised to n upon n square. This is the infinity by infinity form by apply L'Hospital rule, and limit n tending to infinity 2 raised to n log 2 upon 2 raised to n raised to 2 minus 1, and limit n tending to infinity 2 raised to n log 2. This is also infinity by infinity form. Limit n tending to infinity log 2 2 raised to n log 2 and upon 2 log 2 square upon 2, limit n tending to infinity 2 raised to n log 2 upon log 2 square into infinity. This is the diverges, therefore this is the diverges. Option D is correct. Next question, if A is equal to limit n tending to infinity 1 plus 1 upon 2 plus 1 upon n, and B is given limit n tending to infinity 1 upon n 1 plus 1 upon 2 plus dot dot dot. Here two example given, A and B. Now find for option. This is the first example. Here n is equal to n tending to infinity 1 plus 1 upon 2 plus 1 upon n. Here n is equal to 1 upon n, and limit n tending to infinity n equal to limit n tending to n 1 upon n equal to 0. Above series sequentially term is monotonically decreasing. So by present test, limit n tending to infinity n into 1 upon n equal to 1 not equal to 0 is a divergent, that is a equal to infinity. This is for a is the divergence. A is the divergence in option 3 given, so D is wrong. Now check for a B. One result, if n is if n converges to L, then the sequence action here action equal to 1 plus a1 plus a2 plus dot dot an upon n also converges to L, or limit n tending to infinity n equal to L, then finally we get this is also L. Now check for a here is a 1 upon n also given and limit n tending to infinity 1 upon n, as n tending to infinity option will 1 upon infinity equal to 0, therefore option A is correct. So option A is correct, A equal to infinity, B equal to 0. Next question, if x1 is equal to root 2 and xn plus 1 equal to root 2xn, n is greater than or equal to 1, then find limit n tending to infinity log e. Here is important, log e xn. Now check for a here given x1 equal to root 2, xn plus 1 equal to 2 root xn, and x1 equal to root 2, xn plus 1 equal to root 2 xn. Now find a limit n tending to infinity log e raised to e into xn. Let xn limit n tending to infinity xn equal to x, and then implies limit n tending to infinity xn plus 1 equal to also x. Xn plus 1 equal to root 2 xn, and square on both side, xn square xn plus 1 square equal to 2xn, and limit as n tending to infinity here x square equal to 2x, and x square minus 2x equal to 0, x into x minus 2 equal to 0, x is equal to 0 and x equal to 2. Therefore limit n tending to infinity xn equal to x, limit n tending to infinity log e into xn is equal to log ex. Here x is a non-zero. If x is 0, log 0 equal to minus infinity, so x must be 2, so x equal to 2, and limit n tending to infinity log e into xn equal to log e2. This is the final answer in option B is correct. Next question, let E be a non-compact but bounded subset. Here given a non-compact and bounded subset of R, x not be a limit point of P, which is not in E, and G from E to R be defined by g of x equal to 1 upon 1 plus x minus x naught square, then which one of the following statement is not true? Here also given a not, here also given not. Here option is G attains its maximum on E. This is also 2 times repeated. Next question, the Cauchy product of the series sum n runs from 1 to infinity minus 1 raised to n minus 1 upon n with itself is now find this is convergent or divergent. One Leibniz test or alternate series test. This is Suppose modulus of C1 is greater than or equal to modulus of C2, modulus of C3, this is and second one is C2m minus 1 is greater than or equal to 0, C2m is less than or equal to 0, m runs from 1 to 3, and the limit n tending to infinity Cn equal to 0, then minus 1 raised to n into Cn converges. Now check for here given minus 1 raised to n minus 1 upon n. This is a conditionally convergent but not absolutely convergent, therefore this is a convergent. Next question, which one of the following is a metric on R? Here given a 4 option, this is also repeated. This is also repeated. Here one result. Here is the one result important. Here is given d of xy equal to mod of x raised to n minus y raised to n is a metric when n is a odd, not a metric when n is a even. Here n is a, now check for what is given. In option A, n is a 2, that is a even, therefore this is a not a metric, and minus here also given minus, this is also not a metric, and x minus y raised to square, this is also not a metric. Here is the one result, d of xy equal to d of xy upon 1 plus d of xy. This is also metric. Here mod of x minus y, here n is a even, that is 1, n is equal to odd, this is a metric, so d of xy upon 1 plus d of xy, that is here option C is a metric. This is an important result. This is important result for a metric. Next question, limit n tending to infinity n raised to root 2 upon 1 plus root 2 raised to n equal to 1 0 infinity root 2. One result based on if n is be a sequence of a real number such that limit n plus 1 upon an equal to L, here modulus of L is less than or equal to 1, less than 1, then limit n tending to infinity n equal to 0. Apply the result and finally we get answer 0. Next question, which one of the following sets is a countable? What is the countable and uncountable? First option given, a set of all sequence whose elements are the digits 0 and 1. 0 and 1, this is uncountable. This is uncountable, and the set of all n tuples of elements of countable sets. Set of all n tuples. N tuples means this is a finite, and n tuples of countable sets. This is a n tuples means subset. Subset of a countable set is also countable. So option B is the correct. The non-empty perfect set. Every perfect set is uncountable, and the set of all transcendental number is also uncountable. So option C D also wrong. Next question. This is from linear algebra. Let A be a non-empty set of real numbers which is bounded below. Here answer is the infimum of A equal to minus supremum of minus A. Next question, 0 to 1 integration 0 to 1 log 1 upon x raised to minus 1 by 2 dx is equal to, here 4 option given, and this is a solution. Here I equal to 0 to 1 log 1 upon x raised to minus 1 by 2 dx is put log 1 upon x equal to 2 and 1 upon x is equal to e raised to 2. then implies x equal to e raised to minus t dx equal to minus e raised to minus t dt as the t tending to infinity tending to 0, and I is equal to minus infinity to 0 t raised to minus 1 by 2 into minus e raised to minus t dt, and minus infinity to 0 t raised to minus 1. Here is a common minus, and I equal to 0 to infinity t raised to minus 1 by 2 e raised to minus t dt. Here is a 10 minus t t raised to n minus 1 dt, n minus 1 equal to minus 1 by 2, n equal to minus 1 by 2 plus 1, n equal to 1 by 2, and I equal to this one, and finally we get this one. This is equal to root 5. So option C is correct. Next question, let f be a real continuous function on a metric space X, then the set of zeros in metric space X, then the set of 0 is always closed in X. Option B is correct. Next question, limit n tending to infinity 1 upon n into 1 upon 1 raised to root 5 plus 1 upon 2 raised to root 5 plus up to 1 upon n raised to root 5 is equal to. This is also one result if n is the sequence of real number such that limit n tending to infinity n plus 1 upon n equal to L. Here modulus of L is less than 1, then limit n tending to infinity n equal to 0. Here given a limit n tending to infinity 1 upon n raised to root 5 equal to 0. Therefore option B is correct. Next question, which one of the following series is a divergent? Here ask, this is also most time repeated. Option C for diverges. Here is a convergent. Log raised to log n into log raised to n. This is a convergent. This is also convergent, and this is less than 1 upon n cube. This is also convergent. So option C is a divergent. Next question, which one of the following is a function of bounded variation on 0 to 1? Here is one result. If f of x is given x raised to alpha sin 1 upon x raised to beta, x is non-zero, x is equal to 0 if 0, then f is a bounded variation if alpha is greater than beta, and f is not bounded variation if alpha is less than or equal to beta. Here given alpha is greater than beta. Here alpha is greater than beta, then bounded variation, otherwise not. Here is given, here alpha equal to 2 and beta equal to 1. Therefore 2 is greater than 1. This is a bounded variation. Option C is correct. Next question, which one of the following series is a convergent? Here ask convergent. Option C is correct. Sum n runs from 0 to infinity arc tan n upon 1 plus n square. Option C is correct. Next question, with respect to discrete topology on the real line R, which one of the following statement is false for the subset Q of rational number? This is a dense. This is also true. Open closed and open closed. Dense is not true. Next question. If A is the subset of a topological space X, then which one of the following statement is false? Here this is correct. Boundary of A equal to A closure intersection X minus A closure, and intr of A intersection boundary of A is a non-empty. Here given this is empty, so this is the wrong option. This is also correct. This is also correct. Boundary of A is equal to 5 if both A is both open and closed. A closure is equal to intr of A union boundary of A. This is correct. Option B is wrong. The function f from R2 to R defined by f of xy equal to x square y upon x raised to 4 plus y square. If xy is non-zero, if 0, if xy equal to 0, then f is not a continuous at 0, 0. Which one of the following statement is the false? Here ask a false statement. Every normal space is metrigible. This is a false statement. Every compact ordered space is normal. This is correct. Every regular Lindell space is normal. Every well ordered set in the order topology is normal. This is also correct. Next question. The set of all limits of the sequence xn equal to 1 upon n equal to 1 to in the finite complement topology on R. Here given set of all limit of the sequence xn equal to 1 upon n as n tending to infinity, limit n tending to infinity 1 upon n equal to 0, and here ask finite complement topology of R, and 0 complement equal to R, so option D is correct. Next question. Let n equal to minus 1 raised to n log n raised to 4 plus 1 upon n square plus 1, then the sequence an converges to 0. This is the answer. Next question. If f and g are a real valued function, then maximum of fg. Here is some result. Maximum of fg equal to f plus g plus f minus g upon 2. Here minimum of fg equal to f plus g minus f minus g upon 2. This is the result. So option C is correct. Next question. Which one of the following has a positive Lebesgue measure in R? Answer is a entry set is a uncountable set with a measure 0. So option here ask a positive Lebesgue measure. Z is also and Q is also. Here option D is correct. AB minus Q where A is less than B. Next question. If f from AB to R take the value 1 at rational and minus 1 at irrational point, then the upper and lower remain integral are respectively. Here 1 is given A and B, minus 1 given as B. Here B minus A and minus B minus A, this is upper and this is lower remain integrable. So option A is correct. Next question. The closed unit wall of a normed linear space X is a norm compact if and only if X is a finite dimensional. Here ask a norm compact. Therefore option A is correct. Next question. Defining the value 0 at x equal to 0, which of the following function is continuous on 0 to pi? Continuous on 0 to pi. Here one result, limit at exist 0 and pi in option C. Option D. Here exist a limit extending to 0, x sin 1 upon x equal to 0. There exists a finite. Therefore option, now check for option pi. Check for pi and limit extending to pi, x sin 1 upon x equal to pi 1 up sin 1 upon pi. This is also exist and finite. So this is a continuous function on closed interval 0 to pi. Option D is correct. Next question. Let f from closed interval ab to r take the value 1 at rational point, 0 at a irrational point. Then f is a Lebesgue integrable and integration a to b f equal to 0. Option A is correct. The function f of x equal to x square from r to r. Here given r to r is a function is given x square. This is the graph of x square and this is a continuous but not uniformly continuous on r. So option C is correct. Next question. Let f from r minus 0 to r be defined by f of x equal to x plus 1 upon x. Pick out the true statement. That is a true statement. f has a local maximum at minus 1 and the value is a minus 2. Option B is correct. The sum of the infinite series 1 plus 1 upon 3 minus 1 upon 2. Here a is a 2 and b is a 1. A is a positive and b is a negative. Find answer, we get 3 by 2 log 2. Next question. Here option is wrong. Next question. Let an be an is a sequence of integers infinitely many of which are non-zero. In general, what can you say about the radius of convergence R of the power series sum of an x raised to n? Here is given sequence integer infinitely many non-zero. Option C is correct. R is less than or equal to minus 1. Next question. The improper integral 0 to 1 sec x upon x dx is this is a solution of that example. Here f of x is equal to sec x upon x. Here x is equal to 0 is the only singular point of f of x. And choose phi of x equal to 1 upon x. And limit extending to 0 f of x upon phi of x equal to sec x upon 1 upon x, that equal to sec 0 equal to 1, that is a non-zero. F of x and phi x are both behave like. Now check for integration 0 to 1 phi of x dx equal to 0 to 1 upon x dx. This is a divergent by p test n equal to 1. So by comparison test 0 to 1 sec x upon x dx also divergent. So option B is correct. Next question. If f of x is equal to x log 1 plus x inverse 0 is less than x is less than infinity, then limit extending to 0 f of x and limit extending to infinity f of x are respectively. Here find the limit extending to 0 f of x and limit extending to infinity f of x. Now check for a limit extending to 0 f of x. Here limit extending to 0 and put f of x is x. Here given x log 1 plus x inverse. Here is x, so option extending to 0. Finally we get 0. So option A, B are correct, B, D are wrong. Now check for in A, B, A, D, A, C. Now check for a limit extending to infinity f of x. Here f of x is given x log 1 plus x inverse and put this value and finally we get answer. So option C is correct. Next question. The sum of the series sum n runs from 0 to infinity arc 10 into 1 upon n square plus n plus 1 is here is given solution. Arc 10 1 upon n square plus n plus 1, and that is written as a tan inverse n plus 1 minus n upon n plus 1 plus 1. This is a solution of that answer. Answer is a pi by 4. So option B is correct. Next question. Let x1 is greater than or equal to x2 is greater than or equal to xk is greater than or equal to 0. Then find the limit n tending to infinity x1 raised to n plus x2 raised to n plus dot dot xk raised to n raised to 1 upon n. Your option is x1, that is greater than. Next question. If u equal to yz upon x, v is equal to xz upon y, w equal to xy upon z given, and find Jacobian of u v w upon xyz. This is a formula for Jacobian. u v w upon xyz equal to dou u by dou x, dou u by dou y, dou u by dou z. And dou u by dou x, dou u by dou y, dou u by dou z, and dou w by dou x, dou w by dou y, dou w by dou z, and find dou u by dou x. This is value, and put this, and finally you get answer 4. Next question. The quasi product of the series is given. Sum n runs from 1 to infinity minus 1 raised to n minus 1 upon n with itself is a convergent by Leibniz test or alternating series test. Find yourself. Next question. Which one of the following statement is a false? Answer is R is a discrete topology is connected. Every path connected space is connected. This is a true statement. The subspace Q of R is not connected. This is also every convex subset of R is connected. This is also true. Option A is wrong. So option A is correct. Next question. Which one of the following is a metric on R? This is a repeated question. Here n is even. So option A is wrong. Here is also wrong. This is also wrong. This is correct. Why? This important question. Next question. If A is a subset of a topological space X, then X equal to interior of A. Here A is given. Here interior of A and boundary of A. Here boundary. This is the interior and interior of X minus A. That is, this is outside part equal to X. So option D is correct. Next question. Let xn be an arbitrary sequence of real numbers such that given epsilon is greater than 0. There exists an n belongs to natural number with the property that mod of xn minus xn plus 1 is less than epsilon for all n is greater than or equal to n. Then the sequence xn is may or may not converges. Option D is correct. Next question. If xn equal to 1 plus 1 upon 2 plus up to 1 upon n for n is greater than 1. Here given n is greater than 1. Suppose n, I take n equal to 2 and put this value xn equal to 1 plus 1 upon 2. This is 3 by 2, and in option B check 2 into 3. Here n plus 1 equal to 3 raised to 1 upon 2. I take n equal to 2. 2 plus 3 by 2. This is we get 3.4 is less than 3.5. So option B is correct. Next question. Let E be a non-compact bounded subset of R. X0 be a limit point of E. X0 does not belong to E, and G from E to R be defined by G of X equal to 1 upon 1 plus X minus X0 square. Then which of the following statement is false? Here G attains its maximum on E. Option C is correct. And this is also a statistic question. For a negatively skewed distribution, the correct statement relation mean median mode. Mean is less than median is less than mode. Option C is correct. Next question. Limit n tending to infinity n upon n factorial raised to 1 upon n equal to E. Option D is correct. The function f from R to R defined by f of x equal to x sin 1 upon x. X is 0 equal to 0 if x is 0. Then f continuous everywhere, continuous only at x equal to 0, not continuous, differentiable. This is a graph of f from R to R, f of x equal to x sin 1 upon x for all x belongs to R. This is a graph of this function. This is a continuous everywhere. So option A is correct. Next question, which one of the following series is convergent? This question repeated. I previously said this is a divergent and this is a convergent, log n raised to log n. Here is a one important notes. Here is a 1 upon log n raised to log n, 1 upon log n raised to log n. Both are convergent. Here this one is a 1 upon n log n log n log n, 1 upon n log n. This is a divergent. This is only two convergent. This is also diverges. And this is a converges only for p is greater than 1. So option D is a convergent. Next question, the sum of the series 2 root 2. Answer is 2 root 2. Next question, integration 0 to 1 log 1 upon x raised to minus 1 by 2 dx. Here is the 4 option given. Here I equal to log 1 upon x raised to minus 1 by 2 dx. Put this value and finally we get this is value. This is finally we get 1 by 2. Option C is correct. Next question, let f of xy equal to y square plus 4xy plus 3y x square plus x cube. Then 0 0 is the saddle point of f. Option A is correct. Let f from R to R, then which one of the following statement is true? Which of the following statement is true? Here given in option A given f is a continuous at a point, then f is a partial derivative at that point. Here is a converse not a true. Therefore option A is wrong. If f is a partial derivative at a point, this is also repeated question. If f is a partial derivative at that point, then f is a continuous. Partial derivative plus bounded, then m plus continuous. This is also wrong. If partial derivative at a point, then f is a partial differential at that point. This is also wrong. This is a true. Differential at a point, then f is a partial derivative at that point. Next question, this is also repeated. Here option is 4. The infimum and limit infimum. Here read carefully. Infimum and limit infimum. Supremum, limit supremum. This is asked. Here first of all, now check for limit infimum. As a limit n tending to infinity, infimum of this one. Here is as n tending to infinity. Here are 2 and here 3. Here infimum is 2. In option check infimum. Limit infimum means second. Here given a second. Option check for second. In option B and D given a 2 only, and C, A not given, so option wrong. Now check for limit supremum. Here as n tending to infinity, we get 3. 3 is the limit supremum, and 2 3 limit infimum supremum. And put n equal to 1 infimum. This one we get 2 minus 1 upon 1, that is 1. And put n equal to 2, supremum of 13 upon 4. This is a supremum of this example. So option D is correct. Next question, let x be an infinite set for xy belongs to x. Define d of xy equal to 1 0 if x is non-zero, if x equal to high. Then which subset of x are compact in the metric space xd? All finite subset of x. Option B is correct. Next question, which one of the following is a true? Now check for option B. Pi raised to 3 is less than 3 raised to pi. Here pi value of pi is a 3.14, and they put 3.14 raised to cube is less than 3 raised to 3.14, that is 30 is less than 31. So option B is correct. Option B is correct. Next question, the radius of convergence of the powers is, that is 2 raised to n plus 1 upon n factorial into z raised to n. Here is a one formula, that is a notes. Radius of convergence of sum a raised to n into x raised to n upon n factorial. Then here a is a non-zero. Then radius of convergence is a infinity. By result, we get radius of convergence is equal to infinity. Here a equal to 2. So option A is correct. Next question, which one of the following statement is the false? Here ask a false statement. A countable union of countable set is a countable. This is a correct statement. The set of all real number x such that 0 to 1 is uncountable. This is also correct, and this is also correct. The set of all sequence whose elements are the digit 0 and 1 is a countable. Here given a countable, this is a 0 1 is uncountable. Here is a uncountable. In option given countable, so option B is wrong. Next question, which one of the following statement is a false? Which of the following is a false? Every convergent sequence is a bounded. This is a true. Next question, every monotonous sequence is a convergent if and only if it is a bounded. This is also direct result. Every bounded sequence has a convergent subsequence. Here given a subsequence. This is also correct. Every bounded sequence. This is a conversion, not a true. So option D is a false statement. Next question, the sum of the series 1 plus 1 upon 3 plus 1 upon 5 minus 1 upon 2. Here given a p equal to p means number of positive. Here number of positive equal to 3 and number of negative equal to 1. Here p equal to 3 and q equal to 1. Log 2 plus 1 upon 2 log 3 by 1. This is a formula. And the log 2 plus 1 upon 2 log 3. Log 2 plus log 3 raised to 1 by 2. Log 2 plus log root 3, that is log 2 root 3. Option A is correct. Next question, which one of the following statement is a false? Any closed subset of a compact space is a compact. This is a true. Any compact subset of a Hausdorff space is a closed. This is also true. A subset of a Euclidean space is a compact if and only if it is a closed and bounded. This is also true. This is a false statement. Next question, if for all x is greater than 0, e raised to x is greater than x raised to t. This is a repeated question. T is less than e. Next question, limit n tending to infinity 1 upon n 1 plus root 2 plus cube root 3 plus n root n is equal to, here one result, if n is converges to L, then the sequence section of a1 plus a2 plus an upon n also converges to L. This is the result. Now find a limit n tending to infinity n equal to L. Here L is here n is given n root n. Limit n tending to infinity n root n equal to 1. This is the option B is correct. Next question, if a is greater than 0, then integration 0 log x upon x square plus a square dx is equal to option A is correct, pi log a upon 2a. Next question, the supremum of the set A equal to P belongs to Q such that P belongs to Q plus such that P square is less than 3 in Q. Here supremum and infimum does not exist. Next question, which one of the following improper integral diverges? Here ask diverges. Here option C is correct. Next question, let alpha be monotonically increasing on closed interval AB. Then the function f from AB to R is a Riemann still chess integrable with respect to alpha if and only if. This is a direct result. For every epsilon 0 to 0, there exists a partition P such that UPF minus UPF alpha minus LPF alpha is less than epsilon. This is a direct result. So option C is correct. Next question. Suppose f is twice differentiable on 0 plus infinity, f double dash is bounded on 0 plus infinity, and f of x tending to 0 as x tending to infinity, then x tending to infinity f dash of x equal to 0. Option B is correct. Next question. The series sum n runs from 1 to infinity 1 upon n sin 1 upon n converges for all a is greater than 1 by 3. Option B is correct. The sum of the series sum n runs from 1 to infinity n upon n raised to 4 plus n square plus 1 is option 1 by 2. Next question. Let sum n runs from 1 to infinity xn be a convergent series in which the terms xn decreases monotonically. Then limit n tending to infinity n xn equal to 0. This is from standard result. Suppose the partial sum an of sum of an form a bounded sequence and bn be a monotonically decreasing convergence to 0. Then b0 is greater than or equal to b1. This is a decreasing sequence and tending to 0, and then implies product also converges to 0. From this result option A is correct. Here convergent and decreases monotonically, so option is 0. Next question, which one of the following statement is not true in a metric space? Every neighborhood of an open set in X. If P is the limit point of the set E is a subset of X, then every neighborhood of P contains only finitely many points of P. This is not true. This is true. This is true. A set E is a subset of X is open if and only if complement is closed. This is true. Compact subset of X is are closed. This is also true. Next question. If n of x equal to 1 plus x upon n raised to n runs from 1 to, which one of the following statement is true? Here ask true. Here is the one result, 1 plus x upon n. Here is a limit n tending to infinity 1 plus y upon x raised to n equal to e raised to y. Here given, here y equal to x, here y is given x. So by this result we get option C is correct. This is very important. Next question, for sequence A and opposite, which one of the following statement is true? Option B is correct. Next question, which one of the following statement is true? Here ask a true statement. A function of bounded duration implies continuous. Here is a bounded implies continuous. Function of bounded duration. function of bounded duration is a not a true. This is not a possible. There exists one example. This is continuous but not bounded duration. So option A is wrong. A continuous function is a bounded duration. Continuous implies bounded. This is also wrong. A function of bounded duration implies bounded. Bounded duration implies bounded. Option C is correct from this result. And a bounded function is a bounded duration. This is a converse. This is a not a true. Option C is correct. Which one of the following is a true? Here sum 1 upon n and sum 1 upon n log n both diverges. Here is a sum 1 upon n diverges by p test. Here n equal to 1. So this is the diverges, and this is one is a one result. Here is a one result. Sum n runs from 1 to infinity 1 upon n log n raised to p. If p is greater than 0. Convergent if p is greater than 1. Diverges if p 0 is less than p is less than or equal to 1. Here is a n is a 1. So this is a diverges. By result, option C is correct. Next question. If for all x is greater than 0, e raised to x is greater than x raised to t. Answer is t is less than e. This is most time repeated. Next question. Which one of the following series is the diverges? This is the option repeated so many times. This is the diverges. Next question. The set x such that mod of x plus 1 upon x is greater than 4. Is the option D is correct. Next question. If f of x is equal to 1 minus 1. 1 if x is rational. Minus 1 if x is irrational. Then in 0 1 we have f of x is not Riemann integrable. Option B is correct. Next question. Following is an example of a function which is differentiable at x equal to 0. Here is given differentiable at x equal to 0 and f dash is not continuous at x equal to 0. In option C, here exists a differentiable at x equal to 0 and f dash is not differentiable. So option C is correct. Next question. Let f of x equal to x square cos 1 upon x 0 if x here given, then in 0 1 which one of the following is true? Here is one result. If f of x equal to x raised to alpha sin 1 upon x raised to beta. If is a bounded duration, then alpha is greater than beta. Here is alpha and here is beta. Here is alpha is equal to 2 and beta equal to 1. So 2 is greater than 1. Option D is correct. Next question. Which one of the following improper integral converges? Option B is correct. Next question. If y is greater than 0, then 0 to infinity e raised to minus xy sin x upon x dx. Is the answer C is correct. Pi by 2 arc plus tan arc tan y. Next question. If En is the disjoint sequence of sets, then limit n tending to infinity En is option A is correct. Next question. Which one of the following statement is always is true in metric space? Here ask always is true in metric space. Disjoint sets are separated sets. Next question. If 0 is less than A is less than B. Here option A is correct. Next question. Limit extending to minus plus pi by 2 1 plus cos x raised to 10x. Here option A is correct. Next question. Let the function f from R2 to R be defined by f of xy is equal to xy upon root x square plus y square if non-zero 0 if 0 0. Which of the following statement is true? Answer is f has no partial derivative at 0 0. Next question. Which of the following is necessarily true on the set S intersection T if X is given and T is given? Now find X intersection T. Here option C is correct. F of x square plus g of x square equal to 0. Next question. Let S be a subset of R. Let C be the set of points in X belongs to R with the property that Xn is uncountable for every delta is greater than 0. Then S minus C is empty. Next question. The series sum n runs from 1 to infinity 1 upon n raised to p is the divergent. Divergent for what value of p? Here p is less than 1, divergent. Here is important. Here 1 to infinity. Then p is less than 1, so divergent. If p is greater than 1, then convergent. In sum n runs from 1 to finite value, then 1 upon n raised to p. If p is less than 1, then convergent. P is greater than 1, then is divergent for finite value. Here ask for infinite value, so option P is less than 1, divergent. An is greater than 0 for all n, and sum of an converges. Then root an plus 1 also converges. This is also repeated. The function of xy, x cube plus y cube minus 63x plus y plus 12xy has a minimum at which point? Here is a no here. Next question. Which one of the following improper integral diverges? Option C is correct. If x belongs to 0, 1 and f of x is equal to 0, 1 upon x inverse with x equal to the integer part of x. What is the 0 to 1 f of x dx is equal to? Answer is 1. Let a be a real valued function defined for all x greater than or equal to 1 satisfying f of 1 equal to 1. Then f dash of x equal to 1 upon x square plus f of x square. Answer is A. If an is equal to 1 upon n, here option A is correct. Here find the limit supreme of n in Pn. Next question. Suppose that f is the twice differentiable on 0 to infinity, f double dash is bounded on 0 to infinity, and f of x is tending to 0 as x tending to infinity. Find the limit x tending to infinity f dash of x is equal to 0. Option B is correct. This is from one result. If n converges to L, then the sequence section also converges to L. Here a limit x tending to infinity n root n equal to 1. Option B is correct. The sequence section defined by xn equal to 1 plus 1 upon 2 is a Cauchy sequence. Xn equal to 1 upon n, Cauchy sequence. If x is the integer part of x, what is the 0 to 11? X cube dx equal to 55. Option B is correct. The series diverges for all x. Diverges for all x. Next question. Which of the following function is not a bounded variation? Here ask a not a bounded variation on the interval 0, 1. By result, here is a result. F of x is equal to alpha. If is a bounded variation, alpha is greater than beta. Not a bounded variation, alpha is less than or equal to beta. So by result, here alpha is equal to 1 in option D, and beta equal to 1. So 1 is less than or equal to 1. This is not a bounded variation. So option D is correct. Next question. Which one of the following series is convergent? Option A by p test. This is a divergent. Here 1 in option B, 1 upon n into n plus 1 is less than or equal to sum of 1 upon n square. Here 1 upon n square 1 upon n square by p test. This is a convergent, so option B is correct. Which of the following is the sufficient condition for f d alpha, integration f d alpha over closed interval ab to exist? Option is f is a continuous on closed interval ab, alpha is a bounded derivation on closed interval ab. Which one of the following statement is not true? Which of the following not true? Here is a countable enough countable set is countable. This is correct. A set A of all sequence whose 0 to 1. This is uncountable. This is also correct. The set Z cross Z. In option D, Z cross Z is countable and Z is countable. The product of countable into countable, this is countable. So option D is also correct. Here given countable. So option C is wrong. Next question. Let n equal to given and x equal to a subset of n such that a is a finite or a complement is a finite. Then which one of the following is not true? Option C, x is not a finite. Which one of the following statement is not true? Here ask not true. If xy belongs to Rx is greater than 0, then there is a positive integer n such that nx is greater than y. This is correct by Archimedean property. Between any two real number there exists a rational number. This is also correct. For every real x and every integer n is greater than 0, there is one and only one real y such that this is you can check this option. Which one of the following statement is not true? Here also ask not true. Every convergent sequence is bounded. This is correct. Every bounded sequence in R contains a convergent subsequence. This is also correct. The set of all subsequential limit of a sequence in R is not closed. A sequence in R is convergent if and only if it is Cauchy. This is also correct. This is wrong. Option C is not true. Limit n tending to infinity 1 minus 1 upon 2 n raised to n plus 1. This is take a screenshot of this notes. Here ask direct result. Limit n tending to infinity 1 minus 1 upon 2 n into raised to n plus 1. Answer is e raised to minus 1 by 2, that is 1 upon root t. Option B is correct. Next question. This is for your homework. This is homework. This is the last question of real analysis. Thank you for watching this video. Give me feedback of this video in comment. Like, share, comment, subscribe. Thank you for watching this video.